So hello guys, welcome back to our YouTube channel. So I am Dheeraj from Smart Interviews and today we will be solving questions from LeetCode Contest. Okay, so here is the first and easy question. So let us try to understand what this question is trying to explain us. Okay, so the question says you are given an enclosed matrix. Okay, and all the elements in this matrix are distinct elements, which is you don't have any duplicate elements. And again, all the elements that are present in this matrix are within the range from 0 to n square minus 1. So all you have to do is to simply implement this class, which is known as neighbor sum class. Okay, so in this neighbor sum class, you have given three functions. Okay, this is the neighbor sum constructor, and this is the adjacent sum function, and this is diagonal sum function. So let us try to understand what we need to do in each of these functions. Okay. So first one, which is neighbor sum function. So in this function, in this constructor, we are given a matrix. Okay, what we are going to do with that matrix, we will discuss while coding. Okay, while coding the solution. Now let us keep our primary focus on these two functions, which is adjacent sum and diagonal sum. So if you look at this, in these two functions, the return type is same, and in both of these two functions, there is only one parameter, which is value. So what we need to do in both of these things is, let us try to understand that with a simple example. Now let us assume this is a sample input. Okay, we have two functions. One is adjacent sum of a value, right? And then diagonal sum of a value. Now let's assume this value is nothing but 4. This value is nothing but 4. Okay, so for adjacent sum of 4 is nothing but, first you need to check, does element 4 is present in a given matrix or not. Here element 4 is clearly present, right? So in that case, what are the adjacent elements of element 4? We have 3. Okay, wait, for element of 4, what are the adjacent elements? Tell me. So we have element 3, which is this, and then we have 5, and then we have 1, and then we have 7. So we have 4 adjacent elements, right? So all we have to do is to simply do nothing but we need to simply do the sum operation of these adjacent elements and return the sum. So what is the sum here? What is the sum that we got? We got the sum as 16. Yes, 7 plus 3, 10, 10 plus 5, 15, 15 plus 1 is 16, right? So you need to simply return this sum. Now what does diagonal sum is trying to tell us is, you will be given a value and you have to do the same thing, which is you need to search whether the value is present in the given matrix or not. Here it is clearly present. 4 is clearly present in the given matrix. Now can you tell me what are the diagonal elements of the value 4? Right, 0 is present diagonal to 4, 2 is present diagonal to 4, and 8 and 2, right? So we got 0 plus 2 plus 6 plus 8. You need to simply do the sum of these 4 elements and return the sum. What is the sum that we got here? 8 plus 2, 10, 10 plus 6 is 16. What a coincidence, we got 16 as our answer. So here you have to simply return this one, which is sum of the adjacent elements and sum of the diagonal elements for both of these two functions. That is what we need to implement. Now, what is the logic that you are able to come up with, right? So one of the easiest approach, like the very basic approach, is if you look at the indices, let me write down the matrix indices: 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Now assume that our element 4 is present here, right? That our element 4 is present at index 1, 1. Now here we are only discussing about adjacent sum. here we are only discussing about adjacent sum first. Okay. If the value 4 is present at index 1 comma 1, then what are the elements that we need to pick? We need to pick an element which is present at index 1 comma 0, 0 comma 1, 1 comma 2, and 2 comma 1, right? So assume that 1 comma 1 is nothing but I comma j. Assume that 1 comma 1 is nothing but I comma j. So to pick element which is present just left to the 1 comma 1, what should be the indexing? What should be the indexing? I should change here? No, right? I should be remaining the same, which is I should be remaining the same. What about j? Yes, j should be changing to j minus 1. Now, in order to pick the element which is present at the right side of this particular element, does I should be changing? No, I should not change. What about j? Yes, j should become j plus 1. What about an element that is present on top of the element, top of the value? Yes, we need to change I to minus I minus 1 and j to j remains same. What about an element which is present at the bottom of this element, bottom of this value? Exactly, I should be changing to I plus 1 but not j. So here the logic is pretty much simple, right? Whatever the value that has been given in this adjacent function, we need to simply search at each index. Is this equal to 4? No. Is this equal to 4? No. Is this equal to 4? No. So on. Okay. The moment when you find the element which is equal to value, you need to simply get the sum of the four adjacent elements using these indexing, right? So this is only for adjacent. Now what about for diagonal? Try to think about it for a minute. Let us say that our value is present at index of I comma j, which is 1 comma 1. So if you found your value at 1 comma 1, then you need to pick only four elements, which are, you need to pick index 0 comma 0, sorry, you need to pick element 0 comma 0, 0 comma 2, 2 comma 2, and 2 comma 0, right? So to pick this first element, which is an element which is present at index 0 comma 0, what should be the indexing should be? Does I going to change? Yes, I is going to change to I minus 1. And what about j? J is also going to change to j minus 1, right? What about this one? I is going to change to I minus 1. J is going to change to j plus 1. What about this one? 2 comma 0. I is going to change to I plus 1 and j is going to change to j is going to change to j minus 1. And what about this 2 comma 2? Exactly, I plus 1, j plus 1. So let's assume that if you are unable to come up with how do we generate these indices, you can think something like very simple. If you are at the ith index and you are doing I minus 1, which means you are going to the top cell. And if you are doing I plus 1, which means you are going to the bottom cell. And if you are doing j minus 1, you are going to the left cell. And if you are doing j plus 1, you are going to the right cell. Okay, understood? So that's it, guys. Whenever you found the value in the matrix, you have to simply use these indices to get the sum. Okay, so let us try to write the code for this. Okay, so first one is in the neighbor sum function, we are given the matrix, right? So what we will do, we will create a new matrix and we will store this matrix in our created matrix. Let us call it as grid. Let me change this to input grid, and we need int n. Okay, so first let me store this input matrix in my matrix, which is input grid, and now int n is equal to input grid dot size. So let us try to implement the first function, which is adjacent sum. So how do I implement this adjacent sum? First, we need to find where this value is present, right? From there, we can get the sum of adjacent elements. But how do I get the value? How do I know where this value is present? Exactly. you just need to simply iterate on the given matrix, which is nothing but for loop int I is equal to 0, I less than n, I plus plus, j equal to 0, j less than n, j plus plus. Now, here, grid of I of j is equal to value, which means once I found this element, once an element that is present at an index of I comma j is equal to value, which is nothing but you need to get the adjacent elements of this particular index. So how do I get the adjacent elements? How do I get the adjacent elements? So I need an element that is present just left to this grid of I comma j and right and top and then bottom, right? So let me declare a few variables. Int left, okay, int left, int right, int top, int bottom. Okay, left is nothing but an element that is present just left to this grid of I comma j. So how do I get that? Which is simply nothing but grid of I of j minus 1, right? What about right? Grid of I of j plus 1. What about top? Grid of I minus 1 of j, right? What about bottom? Grid of I plus 1 of j, right? That's it. Did I get all the 4 values? Yes, I did get all the 4 values. Here, I just need to simply return the sum of these 4 values. So I can simply do left plus right plus top plus bottom. Will this work? Now assume that the value that I pass in this adjacent function is 3. Assume that the value that I will pass in the adjacent function is 3. If I pass 3, you will get an element which is present just left to this 3. But is there any element just left to this element 3? No. So according to this code, what you will get? You will get a runtime error because you are accessing an element which is present outside of this matrix. You are accessing an element which is present outside of this matrix. So what should we do? Exactly. We need to put some conditions here. What is the condition here? So here we are doing j minus 1. First, we need to check, are we pointing at the right index or not? So here I can simply do j minus, is j greater than 0 or not? If j is greater than 0, which means if I do j minus 1 also, in the worst case, I might be pointing at the index 0. So if I am pointing at the right index, I will simply return this value, or else I will simply return 0. What about second one? J less than n minus 1. Okay, the same thing, valid index, return the value, or else return 0. What about this? I is greater than 0, or else simply return 0. What about this? I is less than n minus 1. If this is valid, return the value, or else return 0. Now I got the 4 values. I will simply return the sum of these 4 values. Now what about diagonal sum? The diagonal sum is also the same. You need to simply iterate on the given matrix. For loop int I is equal to 0, I less than n, I plus plus, and j is equal to 0, j less than n, and then j plus plus. Once you found at this index, you are having the same value as the parameter value. Now you need to get the 4 elements which are present on the diagonal side, right? So how do you get this left element, right element, bottom, the left bottom? How do you get that? Here, can I simply do sum equal to 0 and then sum plus equal to, you can simply refer to the indices that we have just discussed, which is grid of I minus 1, j minus 1, sum plus equal to grid of I plus 1, j plus 1, sum plus equal to grid of I plus 1 and then j minus 1, sum plus equal to grid of I minus 1 and then j plus 1. Can I simply do this? I mean, you can do this, but there might be a case where you're pointing the indices outside of the matrix range. right? So in that case, we need to put some conditions. What is the condition here? So if I minus 1 is greater than or equal to 0 and j minus 1 is greater than or equal to 0, then simply return this value or else return 0. Okay, the same thing here as well. If I plus 1 is less than n and j plus 1 is less than n, simply return this value or else simply return 0. Okay, and the same thing here as well, which is I plus 1 less than n and j minus 1 is greater than or equal to 0, right position, return the value or else return 0. And here also I minus 1 is greater than or equal to 0, j plus 1 is less than n, give this value or else return 0. Here I will simply return the sum, because once you found this value and you get the sum of 4 adjacent or diagonal elements, you don't need to iterate on the rest of the elements, because you are never going to find this value again, because in the question he has mentioned that all the elements that are present in the matrix are unique. And here we will simply return minus 1 because the return type is of integer. That's it. Let us run the code. Okay, let me change the whole screen. Okay, I think this is not working. Int n is equal to 0. Accepted. And it is submitted. But you know what? If you explain the solution, interviewer will say, okay, but can you come up with something else? Can you come up with any other logic? Because if you see here, if I call this function adjacent sum 1,000 times, then you are iterating on the matrix 1,000 times, which is not kind of optimized, right? Here it is working because the constraints are very low. The matrix size is 10 cross 10 in the worst case. But still, what if the matrix size is very huge? This logic will not work for sure. Why? Because every time I call this function, you are iterating on the matrix every time, right? So can you come up with any other logic? We will discuss. Okay. So just a second. So here, first think here all the elements are unique, which means there are no duplicates. That is the first observation. Second observation is, let's say in this function, in the adjacent sum function, I will pass some value. So what is taking so much time in our previous logic? Tell me. You are just simply searching where this value is present in the given matrix. That iteration itself is taking so much time. Can we optimize that iteration part? If yes, how? How can you know whether this element is present at which index in an instant of time? Which data structure can we use to optimize that? If you have guessed it as a map, then you are right. We can simply use a map. But of what data type? We cannot use an int comma int, right? Because here at each, in order to get this value, you need two indices. One is I and one is j. So it is not going to be I int comma int. Then what type of data structure are we using here? So here we are using a map of int comma pair of int comma int. This is the map data structure that we are using. So in the first field, we are simply storing the value. So here 2. we are simply storing the value. And in the second field, we are storing at which index is this value present. Here, this is present at index 0, comma 2. This value is present at index 0, comma 2. This is how we are storing. Okay. So first, let us try to implement the logic till now. Okay. Okay. So here, the logic is kind of same. So I don't need to change most of the things here. I just need to change few things. First one is I need to declare a map. I need to declare a map. So unordered map of int comma pair of int comma int mp. Let me call it as mp. And the reason why I am using unordered map means I don't need to maintain the order of the data. Whenever I insert any data into my map, I don't need to store it in ordered manner, right? So that is why I am using unordered map. Since we are not maintaining any order of the data, it is going to take average, I mean constant time. Okay. So all of these will remain the same, but here in the neighbor sum function, when I call this, I need to simply insert all these elements into my map. So to insert that, for loop int I is equal to 0, I need to simply iterate on the matrix j less than n, j plus plus, then map of grid of I of j is equal to I comma j. That's it. This stores, okay, this grid of I comma j, this value is present at index of I comma j. Okay. So we have done the storing part. Then what else? Let us come into the adjacent sum function. So here we have seen that we don't need for loops. So let me get rid of that. Okay. So we have gotten rid of this for loops, and we also don't need this condition as well. Okay. So tell me, what should I do here? So first I need to check whatever the value that I'm getting, I need to check whether this value is present in my map or not. So how do I check that? I can simply use the inbuilt function, which is map.find of value is equal to map.end. If this is true, I will simply return -1, because if it is -1, if it is map.end, this value is not present in the map. Okay. Now what is the next one? What is the next step? I need to get the indices, right? So for that, I will declare a pair of int comma int p is equal to map of value. Okay. Now I will simply get the index from I equal to p dot first, j is equal to p dot second. Done. Okay. Now what should I do? The remaining entire code will remain the same. The remaining entire code will remain the same, which means I and j, right? And we will do the same thing here as well. So let me get rid of this, and I don't need these two. Okay. Let me change this to here. I think this is for global. Yep. Okay. So here as well, we will first check whether this value is present in the map or not. If map.find is equal to map.end, then simply return -1, or else pair of int comma int p is equal to map of value int I is equal to p dot first, j is equal to p dot second, and the remaining code entirely will be the same. That's it. Let me run the code. I think there should be one closing bracket here as well. Okay. Yep. I need to declare the sum, right? Okay, I cannot have two, but still it is accepted. So it is accepted. So in this code, we have optimized that we don't need to iterate each and every time whenever we call this function. If you like this video, please do share, like, subscribe, and see you in the next video.